Okay, so basically I was like, hey dad, do you want to go to lunch?
I say I got a 90 on my physics exam, and I only was able to watch one lecture. So
holy shit,
no,
you're a genius. Okay, howdy. Hey, great. Yeah, it's good to see you again. So today I have two announcements. First one is that we will have a quiz today. So as always, you can solve it in WebAssign. I will let you know the password at the end of this lecture. And there are time window from 2:45, which is just time of the end of this class, and to 11:55. And you can have 15 minutes to take the quiz. And as usual, you need to use your Lockdown browser. And oh yeah, it is also again open book test. So you can refer your books or your lecture notes, but do not just Googling or just use a calculator in Wolfram. So yeah, and that's why I use the Lockdown browser in this case. So okay, so you can take it, but also I want you to know that even if the deadline is 11:55, but I strongly recommend you to start at least 11:40 p.m. because yeah, it is just deadline for all the quizzes. So if you started, for example, at 11:50 p.m., then you have only 5 minutes to finish the quiz. So please start before it. So yeah, there's one announcement. And the other announcement is that, yeah, maybe some of you found that the due date of the homework 5 is changed to tonight, right? But it is not true. We changed it to Saturday as usual. And I think that I had a mistake on, changing the schedule. But anyway, so the homework 5 of the WebAssign, its due date is Saturday night. So don't worry too much about this. And yes, this homework counted as your grade. Yes, it is counted as your homework grade. And again, this quiz 4 is counted as your grade, your score on exam 1. So which means that its free credit is 5 points. And if you earn free credit on the exam 1, then if you earn the free credit on quiz 4, then you got 105 points on the exam 1 total, right? So yeah, so I hope that it's not that difficult. So if you're familiar with what we did with in the last time and in the last Thursday, then you are fine, right? Okay. Do you have any question on quiz or homework or anything else? And again, yeah, if you have any problem on using Lockdown browser, then just let me know about event and I can talk to you with Zoom. And yeah, now I'm pretty expert on how to deal with the Lockdown browser. So please email me if you have any problem on using Lockdown browser, right? Okay. Great. Okay. Do you have any other question? Good. Okay, so let's deal with the review on what we did with in the last time. So in the last time, I think that the most important feature is this table, right? So what we deal with, if you have some given data, then you need to know what the mean is. Mean is just the smallest data among the all of one. Then max is the largest observation from all of the data. And range is just difference of max and mean. And mean, actually, I'm not sure why pronunciation is distinguishing mean and mean, but this mean means that just average of the data, one of the average of data, so that it can be calculated by sum of the data and divided by the number of data, right? To get this mean. And median is just an observation, which is middle of the data. So, and mode is just some observation which occurs frequently among all of the data, right? So in mean and median will be only one, but mode may exist or may not exist, or it may be 2 or 3 or whatever, right? So mode is not just one. And Q1, Q2, and Q3 are needed to make quartiles of the observations. So what we want to do is just basically decompose our data into 4 parts. So first first part, and next first part, and second first part, and last first part, and it's called quartiles. And the Q1, Q2, Q3 are some measure distinguish those quartiles, right? So Q2 is just median of the data, and Q1 is the median of the data below the median M. So in this case, the first half, if your data is ascendingly ordered. And Q3 is just median of the last half of data. So in this case, it is just last half of data, which is greater than the medians. And IQR is difference between Q3 minus Q1. So interquartile range is used to determine whether your data has an outlier or not, right? Okay. So these are what we did in the last time. And using this one, we can draw the box plot looking like this. And also we can just figure out what the outlier is. So if your data is outside of 1.5 times IQR in the left, or outside of 1.5 times IQR in the right, then your data is outlier, right? So you can figure out which observations are outlier or not using this IQR, right? Do you have any question on this? Great, then let's deal with next case. So here are some examples of data with histogram. So first data has 3, 3, 3, 3, 3. So in that case, our histogram is drawn as here, right? The all data is 3. And again, mean is 3 and median is 3, right? But when you see the next data, then it has again 2, 2, 3, 4, 4. So your mean is 3 because if you add everything, then what you can get is 15, which is the same as the first data. But also median is 3. But this graph definitely different with the first one, right? So this middle one is definitely different with the first one because in the first one, everybody's at the same value, right? But in the middle one, you can see that some of the data are less than mid-mean, but some of the data are more than mean, right? So it's a little bit different, but they have the same mean or median. And the last data, in this case, 2 of them is just 0, but 3 of them is just 5. But still, if you add all the data, then what you can get is 15. So mean of this data is 3. And median of this data, in this case, it is just the middle one, which is 5. So if you already see the mean of the data, then you cannot distinguish those data, right? But from the perspective, if you just see this picture, then see that in this case, all data are actually aggregated in the mean, in the middle, but this data is a little bit dispersed. And for the last one, the data are polarized, right? So some of them goes to the left side and some of them goes to right side. So maybe these one and these one are some different groups, right? So maybe they have some different characteristics in future. So to distinguish those things, we need not only the mean of the data, but also some other amount. So we want to measure the deviations of data, right? So measure the deviation of data from mean, right? So in this case, in the first case, every observations are actually just the same as the mean. But in the last case, actually every observations are very distinct with the mean, right? So to measure the deviations of the mean, we use the concept of standard deviation, right? So standard deviation gives us a way to say how far away the actual data values are from the mean, right? So it is measure of the spread, right? And it is defined as below. But yeah, but instead of just memorizing this, just let's think about how can you measure the deviation of the data. So for example, let's start with this one, 2, 2, 3, 4, 4. It is actual data, and our mean is 3, right? So deviation for each data is just difference between them. So this one has deviation -1, 0, 1, 1, right? So what we want is just average of deviation. And to get the average of deviation, maybe one of the ways we can use is just using the mean of these deviations, right? But in this case, actually in any cases, if you just add all the deviations, then what you can get is just 0, right? Because 1 plus -1 is canceled out, and 1 plus -1 is canceled out. So if you just add your deviation directly, then you cannot get any meaningful information, right? So instead, we can just scale our deviations to turn out the negative term into the positive term. So what you can get is -1 square is just 1. So 1, 1, 0, 1, 1. And then now if you add everything, then what you can get is just 4. And you can divide it by your number of data. So in here is 5. But we scaled our deviations, right? So we need to get back. And to get back, we just get square rooted on our result, which is 2 square root of 5. Oh, sorry. Give me a second, I muted. Okay. So that's why this equation comes up. So this equation means that the x1 minus x bar is, or x2 minus x bar is just this deviation, and we scaled it and add everything and divide it by n minus 1. Actually, there is some reason, but I do not tell you about this because it is a little bit, a minor reason. Okay. Actually, it is 4. Oh, sorry, thank you. Yeah, it should be 4. Yeah. So. Sorry, yeah, it should be 4. Oh, then it should be 1. Thank you very much, Abiel. Okay. So yeah, and scaled it and divided by n minus 1. And again, get back to our scale. So take the root, then you can get the standard deviation, right? And since it takes the square root, so sometimes it is a little bit difficult to get the exact value, right? Because, square root gives us some, square root 2 or square 3, which is just some number which we didn't deal with in the calculator. So sometimes they just use the variance, which is just square root of the standard deviation. It means that we just do not take square root from our calculation. So variance is just something in the middle step we can get except the taking square root. And standard deviation is taking the square root on your variance, right? Okay. Okay, so do you have any question on the concept of standard deviation? So in the actual exam, I will require you to give such a small amount of numbers and calculate the standard deviation by on your own. And to do this, maybe this table is helpful for you. So let's try to calculate some standard deviation together. So this table in the right, actually it is not in the right, it is below. Yeah, gives the average monthly temperature in 4 different months of San Diego. Yeah, San Diego and Chicago. So find the mean, standard deviation, and variance for the temperature. So in this case, you can get the mean first. So in just degrees San Diego first. So here I'll say San Diego. And San Diego, to get the mean first, you need to add everything. And if you add everything, then this one is just 65 plus 65 is 130 plus 3. And this one is 75 plus 75, which is 150 plus 1. So it is 280 plus 4, 284. And yeah, my calculation correct. And you need to divide it by 4 because we have 4 data. So if you divide this one by 4, then what you can get is 71 because 4 times 7 is 28 and 4 times 1 is just 4. So it is 71. So your mean is 71. So just write down it in the table. And what I write down X is just, we do not need this table, right? So just ignore them. And then you can get the deviation. 65 minus 71 is minus 6. And 68 minus 71 is minus 7, minus 3, sorry. 76 minus 71 is 5. And 75 minus 71 is 4, right? So, but you know that again, if you just add those deviations, then minus 6 plus minus 3 is minus 9, but 5 plus 4 is just also 9, so what you get is just 0, right? But that's what we don't want to get. So you need to scale for the deviations. Then what you can get is square of 6 is 36, and square of 3 is just 9. And 5 to the 2 is 25, and square of 4 is just 16. Then you can add all these things to get 36 plus, sorry, I need to refer my previous calculation, 86. So if you add everything, then you can get 86. Then you need to divide by n minus 1. So here n is 4, passive. So here n is 4, so n minus 1 is 3. So you need to divide 86 by m3, then what you can get is 26. So okay, so 28 something, right? But I just write down to avoid the decimal notation. So it is 6 over 3. So it is 26 plus 2 over 3. Oh, no, not 20. 28, sorry. 28 plus something, 2 over 3. And take square root, then what you can get is square root of 86 over 3. So in the calculation in the exam, you don't need to calculate this approximate value. So just write down using the exact notations, then you are fine. So nobody want to deal with the decimal one. So in this case, just write down it as your rational form and take a square root, then you are fine. Okay. Do you have any question on this San Diego example? Okay, then let's deal with the Chicago example also. So here, Chicago has this 29, 59, 84, 64. So again, if you add everything, 29 plus 59, 84 plus 64, then this one plus this one is just 30 plus 60, which is 90 minus 2. And this one is 148. So it is 23.6. Okay, it's 206.36. And we need to divide it by 4. So it gives us 59. So our mean is 59. And again, you can get the deviation. And what you can get is minus 30, 0, and 25, and 5. And you can scale it to get 900, 0, 625, 25. And if you everything, then add everything, then you can get 15, 50. And you need to divide it by 3. So, and take the square root, and square root of this value, right? Square root of 1550 over 3. And from this, the last question is which city's temperature varies more? And you can see that the Chicago one has the greater numerator compared with the San Diego ones, right? Standard deviation of San Diego. So Chicago varies more than San Diego because standard deviation of Chicago is greater than that of San Diego. Okay. Do you have any question on this? Or anything else? Or any comment? Great. Then let's deal with the normal distribution. So if you just do some examples in the nature or in the in the real world, not real world, but in some part of nature, actually, for example, if you just experiment on tossing the coin to writing down whether your result is head or tail or something like that, then you can see that actually almost all data are combined in the middle, and there are very small data in the right side or left side. So your graph a little bit looks like this bell curve. And in the 18th century, some of the physicists and mathematicians found that some of the natural phenomenon actually converges to the distribution, something called normal distribution. So that's why we run this normal distribution, because in the actual world, we don't have time or cost to figure out all the data. Except the US Kansas, there are no such a thing to figure out all the data and combining to get the meaning. But instead, we can just pick some samples or pick some witnesses of the all data to figure out the how the big data looks, right? And to infer this, we just use the assumption that actually those data follows some distribution, which is called normal distribution, right? And maybe you can learn about this, you can learn about this more in the it's sophomore course or upper division course about the central limit theorem, but I do not deal with this in this course. So what I want to tell in this course is that a lot of data, especially the data we deal with in this course, follows the normal distribution, which means that if you just do the experiment infinitely, then your data distribution looks like converges to or very similar to this normal distribution. And we can use this normal distribution to infer the distribution of your data, right? Using this. So this example is about the 100 pair coins were flipped and the number of heads was counted. And this experiment was repeated in 114 times and result is shown in the histogram. So in that case, first of all, the question is, how many times were 45 or fewer heads observed? So here is 45. So 45 or fewer heads observed is here. Then what you can get is, it is 1 plus 1 plus 3 plus 3 plus 1 plus 3 plus 4 plus 6, right? So 1 plus 1 is 2, 6 3 plus is 6, 1 plus 3 is 4, 4 plus 6 is 10. So if you add everything, then you can get 22, right? And what proportions of the time the were 45 or fewer heads observed? So in the whole proportion, it only 22 cases observed. So, and we know the whole proportion is just 115 because this experiment was repeated 115 times, 14 times. So in this case, we just write down this notation. I do not explain what the notation is, but this means that the X is the something we want to consider. So our experiment, well, you can just thinking it as an experiment. So our experiment gives us the value less than or equal to 45. And the probability of our experiment, it gives us less than or equal to 45 is 22 over 115, right? So that's the meaning, but you don't need to remember it because to run this notation, you need to take the probability course, but that's what I don't know what they read here. So just remember that, it is just proportion of the time the word 45 or fewer heads observed is 22 over 114, right? Then you are fine. And the next question is, what proportion of the time were more than 50 heads observed? So here, more than 50 heads observed is from here to here, right? And if you add those things, then what you can get is 20 plus 7 plus 9 plus 4 plus 5 plus 3 plus 2 plus 1 plus 1 plus 1. So last one is plus 4, and this one is plus 10, and this one is plus 20. So it is 46, yes. Mm-hmm. Yeah. What I did is here, right? So I already did the count for the right proportion of the data, but the whole data is including this part, right? So that's not the one. Is in your question or? Yes. Over 4. It's not the over 4, but I just want to calculate it by part. Because it's not over 4. Yeah, it's not over. It just say that just add this one, add this part. Yeah, that's how I add them. Yeah. Thank you. And sorry, sorry for confusion. Yeah. So what I did is just, it's not the over. It's just over, sign of over. Yeah. Oh, sorry. Yes, so okay, I just write down it here to do not avoid this. Yeah, now it's more clear, right? Okay, thank you. Okay, great. Yeah, and 46, and proportion of the time is 46 over 114, right? So that's the proportion. And the last question is about, can we approximate this with the bell-shaped curve? And yes, and because, if you just draw your bell-shaped curve in here, then it's not the same, but it approximately, approaches to this bell-shaped curve, and its mean is 15.28, and standard deviation is 5.1. So you can see that bell-shaped curve as a region below. Yeah. So, and the reason we use bell-shaped curve is to approximately find the portion of some region in the data, right? So, because bell shape is already calculated by several mathematicians, and it gives us the best approximation for given data. So that's why we use bell shape curve to approximate it, right? Okay. Do you have any question on this normal curve or example or anything else? Question? Oh, good. Okay, great. Great. Then let's deal with the definition. So this bell-shaped curve is called normal curves or normal distribution. And some information about this normal distribution is the peak of the curve is where the mean is located, right? So for example, in the green curve, the mean is -2. So okay, I'll write down as a green. Mean is -2. But this blue curve mean is 0. But this pink curve mean is 2, right? So where you pick here is where your mean is here, right? So, and this mean of the normal curve is called for mu, which is green letter used for this distribution. And the normal curve above all have a standard deviation of 1. And so the highest mean of the data is just 2, right? Pink curve. That's the first fact. And second fact we can use is that this curve is symmetric about the mean, right? So if you're thinking about this mean, then they are symmetric for left side and right side. So mirror image around the mean. And the last fact is that the spread is determined by standard deviation. So we use sigma, which is also green letter, to denote the standard deviation of a curve of the distribution. And actually asks us that how would you find the probability with only means and standard deviation, not graph? Because actually, as I said in the earlier, this bell-shaped curve is already calculated by mathematicians. So if you know the mean and standard deviation, then you can find, for example, if you want to find the proportion of some region, like this region, then you can just know, if you know this point and this point, then you can use your mean and standard deviation to figure out this graph. So yeah, we do not deal with how can we figure out it, but what I just want to say is that there are some equations which gives us that the proportion of this one can be calculated using mean and standard deviation of the graph if your data follows the normal curve. Right. Thank you, Ashley. Okay. But that's a good question. Yeah. So and that's why we use the normal curve, because it is much more easier to figure out such a proportion without knowing much of thing. So if we know mean and standard deviation, then we know all of the thing for this normal curve. So that's why we use this curve for calculation. And again, so number 3 is about the spread is defined by the standard deviation. Actually, that's why we can calculate the proportion. So if you're, for example, this A has some small standard deviation, but your B has some, bigger standard deviation, and C has much greater standard deviation. So if your standard deviation is bigger and bigger, your peak goes down and down, right? So they all A, B, C are the same normal curve. The normal curve is the same mean, but their standard deviations are different, right? So standard deviation of A is less than standard deviation of B, which is just less than standard deviation of C, right? But their mean mu is all the same, right? And st.dv is just abbreviation for standard deviation in the Excel, right? So highest standard deviation is C, and the lowest one is A, right? Okay. Do you have any question on this general information or anything else? Okay, so, and we call the specific normal curve that has mean 0. So 0 is our mean, and standard deviation of 1 is called the standard normal curve. And this curve is important because even if we have several we have several normal curves with distinct mean and distinct standard deviation, but you can always change your normal curve into the standard normal curve to calculate your proportions, right? And that's the cool fact of this normal curve. So if we already know how to calculate the proportion of the standard normal curve, then you can calculate any proportion of any normal curve, right? So that's why we call it as a standard normal curve, and it is called the standard one. And you can see that actually this is standard 0, and -1 and 1 is just the sigma, which is called the standard deviation, and it is called 2 sigma sometimes, and maybe 3 sigma, and so on, right? So we usually say that the given observation is below a standard deviation, or given the observation is in between 1 standard deviation to 2 standard deviation, then what we mean is that the first one, when we say that a data is 1 standard deviation above or below the mean, so this statement says that your data is inside of here or here, right? So since this is the sigma, our standard deviation, so your data is above the 1 standard deviation, so in this part, or below the standard deviation in this part, right? So that's usually we can figure out our data. So let's deal with some example. 8.3. So, oh. Okay. So we have some washing machines that has your usual right with mean of 12 years and standard deviation of 4 years. And the example says that draw normal curve with this mean and also mark locations that are 1 to 3 standard deviations above and below means. So yeah, definitely if you just draw, then I'm not gonna ask you to draw the exact one. So just draw your standard deviation. Oh, it's bad, sorry. Okay, I will just draw our bell-shaped curve first, then put it in. Oh, okay. I'm not good at drawing, so, but yeah. Okay, now it's much better. Okay, so just draw your standard deviation, just draw your bell-shaped curve and put your, here is 12 and 1 standard deviation below is 8 and 1 standard deviation above is 16 and 2 standard deviation below is 4, but above is 20 and 0 and 24. So it's sigma to sigma minus sigma to minus 2 sigma minus 3 sigma and 0 sigma 2 sigma 3 sigma. So we located the 1, 2, and 3 standard deviation and above and below the mean. And what value is 1.3 standard deviation above the mean means that it is just mean is 12, right? So it is mu plus 1.3 times sigma, but we know that mu is 12 from mean of 12 years, and our sigma is 4. So what you can get is 12 plus 1.3 times 4, which is, okay, 5.2, sorry. Oh, no. Above, sorry, not 5.2. 1.3 times 4 is 5.2. Yeah, so 12 plus 5.2, which is 17.2 years, right? So maybe it should be in here. And what value is 0.8 standard deviation below the mean? So it is below the mean, so we need to put negative sign on 0.8 times standard deviation. So it is 12 minus 0.8 times 4. So it is 12 minus 3.2. So it is 8.8 years. So it should be here, right? So these are the meaning of some value is something times standard deviation above the mean or below the mean. Okay. Do you have any question on this example? 1.3 times sigma, sorry, yeah. Again, it is not the 6. So yeah, actually that's my problem that I do not distinguish sigma and so sigma looks like this, but 6 looks like this. So it is very similar, but what I say here is sigma, not the 6. Oh, it looks like 6. Okay. Sigma. It's not the 6. And here sigma is 4. So, okay, yeah. Sigma. Oh, maybe I think that from this notation, our sigma should have smaller tails. So maybe I write down if it's smaller tail, then it looks like much more sigma. But still it looks like 6, so okay, sorry about that. So I will write down sigma as a blue notation and 6 as a black ink, so that you can distinguish it. Thank you. And do you have any other question? Is everything good? Great. Okay. Okay, great. Then let's deal with definition 8.4. And actually, that's what I said earlier, that we only need to know about the standard normal curve. So this Z-score is measurement of this X is how many standard deviation, and measurement is away from mu. And to calculate the standard score G, one can have the formula G is equal to X minus mu over sigma, right? So actually the meaning of this G-score is that if we know what our mean and our standard deviation of our normal curve, then you can change it as this G-score. And using this G-score, actually this G-score is correspond to some point in the standard normal curve. So using standard normal curve, we can find out the proportion of the data which is greater than this X or which is below than this X, right? So that's why we calculate the G-score, and that's why we use standard normal curve for calculation. So let's deal with some example to how to calculate this G-score first. So in the above example, if washing machine lasts 17 years, what is its G-score? And it means that G is 17 minus our mu is, oh, sorry. I write out in the black ink. So G is 17 minus mu over sigma, but this one is the same as 17 minus 12 over 4. So it is 5 over 4, 1.25, right? And it means that if you have a bell-shaped curve with mean is 0 and standard deviation is 1, then it means that this point is actually here, 1.25. So, yeah. So I just want to show that why we need to calculate the G-score. So we have different, the original bell-shaped curve. This. So can you see this? So this one is the original normal curve. The above one is original normal curve. And the below one is just standard normal curve. But the both has the same graph, but with different, I don't know this English word. So everybody knows Google Maps, right? And when Google Maps. And if you use Google Maps, then you can just zoom in or zoom out, right? So like this, we can just a little bit zooming out of our original normal curve to make that the 1 in the standard normal curve 1 in the from 0 to 1 is correspond to 0 to 4 in the normal curve by zooming out, right? So this original normal curve is just zooming out something. Then if you just zooming out something, then you can actually change your normal curve into the standard normal curve, right? And this, then your 17 is actually changed to 1.25. And that's the meaning of our Z-score, right? So if you just zooming out and zooming in to making your original normal curve into the same shape as the standard normal curve, and Z-score gives us the position of your original data in this standard normal curve, right? Does it make sense? And Morgan says, how does 6 turn into 4? And that's what I said in the reviews, that I will say that blue 6 is actually sigma, this notation. And this black ink 6 is just 6. So sorry for my bad writing, but this sigma looks like 6. So that's what your confusion about that. But in here, it is sigma, not the 6. Great, thank you for question. Okay. Okay, do you have any other question? Oh, this is supposed to be 8. Thank you, Dawson. Yeah, that was a mistake. Yeah, this is supposed to be 8, yes. I just thinking about the sigma, yeah. And Karen says that you can try drawing sigma like O or 0 and just put a little tail at the top. Thank you, Karen. So just like O and put the head. Oh, it's much more better than 6. Thank you, great, Karen. Okay, I'll use this notation. Yeah, great. Okay, let's deal with the second example. How many years would a washing machine last if its Z-score was minus 1.8 years? So in that case, what we can do is, first of all, we need to get the Z-score is. So Z-score is minus 1.8. And this is the same as x minus 12, which is our mu, over 4, which is sigma. So you can just multiply both sides by 4 to get minus 1.8 times 4 is equal to x minus 12. So x is equal to 12 minus 1.8 times 4. And 1.8 times 4 is 77.2. So it is 4.8, right? So how many years is just 4.8 years if your Z-score is corresponds to negative 1.8 years, right? So again, if you just put it here, and or here I should put minus sign. Okay. And maybe minus 1.8 is at this point. And this corresponds to 4.8. Okay. Does it make sense? Okay, let's deal with the next one. So normal distribution has a mean of 50 years and standard deviation of 8 years. And I just want to find our Z-scores for the following values of x. So here, x is 42. So our Z-score is 42 minus 50 over 8. So 42 minus 50 is just minus 8 over 8, which is minus 1. And again, 38 minus 50 over 8 is 12 minus 12 over 8, which is minus 1.5. And 60 minus 50 over 8 is 10 over 8, which is 1.25. Right? So it's just using the formula of Z-score. And if your Z-score is negative 2.1, then value of X is negative 2.1 is X minus 50 because our mean is 50 and standard deviation is 8. So from this, you can just multiply both sides by negative 8. Then what you can get is 8 times minus 2.1 is equal to X minus 50. And you can add 50 for both sides. 50 plus 8 times minus 2.1 is X. And minus this 8 times negative 2.1 is minus 16.8. So it is 33.2. So X is 33.2. Okay. Do you have any question on Z-score? Okay, now we can, now we know how to put our point in the standard normal curve, right? So using this, we can, now we can find the proportion of some region in the standard normal curve. So first of all, what you need to know is that our Q1, Q2, Q3, which is we learned from the quartiles, is that it is actually, so if you have the normal curve, then for example, if you have minus sigma, okay, so I'll just assume that our mu is 0 to notation, sigma and 2 sigma and 3 sigma. Then what you need to know is that actually Q1 is mu minus 0.67 sigma. So it is actually almost 2/3 of the sigma. So it should be here. That's our Q1. So it is minus 0.67 sigma. And the Q2 should be, our median should be, like, it's just mu. And Q3 is in here. So it's 0.67 sigma. Okay, again, I use the notation. So just, you can know. So this example says that where are the first and third quartiles in the normal curve? We mean of the 50 years and standard deviation of 8 years. So in this case, what we know is that our mean is 50, so mu is 50, and sigma is 8. So Q1, the first quartile is 50 minus 0.67 times 8, and which is 50 minus 5.36. So it is 44 times 64. And Q3 is 15 plus 0.67 times 8. So it is 50 plus 5.36. So it is 55 times 36 years. And for the washing example, we had mean is 12 and standard deviation is 4. So what values of bracket in the middle 50% of the data? So when you see the washing example, yeah. Here, the middle 50% of the data is just from Q1 to Q3, right? Okay, I just used this one. So again, we can put our Q3 and Q1 is here. So maybe this one is Q1 and this one is Q3. Then middle 50% is inside of here, right? So what you can get is, first of all, we need to figure out what the Q1 and Q3 is in this case, and we can figure out this data. So Q1 is 12 minus 0.67 times 4. So 12 minus 2.68, so it is 9.32. And Q3 is 12 plus the same number. So it is 12 plus 2.68, so which is 14.68. So middle 50% data is in between 9.32 years and 14.68 years, right? Okay. Do you have any problem on those two examples? Or do you have any question? Okay, great. Then, yeah, oh, that's what I want. So, okay, now the last one is just 68, 95, and 99.7, which means that, so about 68% of the data is within the one standard deviation means, which means that if you just taking the proportion of your data from -1 sigma to +1 sigma, then it takes the 68% of the portion, right? And the same reason, about the 95% of the data is within 2 standard deviation of mean, which means that if you just take the data from mu -2 sigma to mu +2 sigma, then it takes the 95% of your data. Actually, it is actually more than 94%, but anyway, so we can just approximate it. And lastly, about 99.7% of data, which is almost all data, are inside of the 3 sigmas, right? So that's why we use this normal curve, because we can just say something using the notation of sigma, right? So since it's business course, so maybe it happens when you are young, but when you have in the 28, we have some financial crisis, right? About the mortgages, right? So if you just look around that point, then there are some reports from Goldman Sachs says that actually the odds of, the odds of financial crash is 25 sigma, or something like that statement, or you can see it from the, I'm not sure it is 28 financial crisis or 20. It is all about the mortgage crisis, so I think that it should be the 28. But the order of is 25 sigma means that actually it is happens in these times, right? So it says that this financial crisis is definitely the very rare cases happens in the right? It usually cannot happen, but it happens in sometimes, right? So a lot of people in the financial industry says that it happens in 3 sigma, or it happens in 2 sigma, or if you learn about the operations, then you can learn about the 6 sigma, operations, right? You need to drop your quality of the, you need to satisfy your quality of your product without errors in, so the portion of your product which doesn't have any error should be inside of the 6 sigma, which means that almost all the data, right? So you can see such an expression a lot from some financial newspapers. So that's what it means. So when they say about the 1 standard deviation or 1 sigma, that it means that your data actually occurs about 68% probability. But if your something happens in 2 sigma, then it says that it is above 5% of the probability it happens. But something says that it is 3 sigma, then it is above 99.7%. So the region for having a chance on getting a 3 or more sigma means that it happens in 0.3% probability, right? So that says that it is just some common expression to show how old your what something happened is, right? So that's why we use this sigma notation. So here, let's deal with some examples. So for the washing machine example, where the mean was 20 years and we have standard deviation of 4 years, then what range of values make up the middle 95% of the washing machine? And from this, we know that 90% of middle are inside of the 2 sigmas. So what we know is that 12 minus 2 times 4 is 4. And 12 plus 2 times 4 is 20. So it means that the middle 95% is between 4 years to 20 years, right? So these are the range of the middle 95% of washing machine here. Do you have any question on this example? Or? Yes. So, sorry, what is your question? We don't have to do anything except look at our chart that already has deviation. Yes, so actually that's the reason why we run the normal distribution, because if we know that our data follows normal distribution, then we don't need to see a chart, right? Just calculate the proportion into normal distribution, then that's okay. So we just want to avoid such a, exploratory analysis. Good, that's good point, Aubrey. Yeah. Is there any other question? Okay, let's deal with more example. So the ranks of a tape on a roll, a certain type of mask is normally distributed. It means 25 and standard deviation of 50 centimeters. So 50 centimeters is actually 0.1 meter. So you can put your per standard deviation as 25.5 and 24.5 and 26, 25 for your 24 for your 2 sigmas, and for 3 sigma 26.5, 23.5. And what is the range of ranks of most, which means 99.7% of the rows? And this 99.7 is just in between 3 sigmas. So it is just between 23.5. Oh, sorry. Between 5 meter to 26.5 meters. And what ranks bracket the middle 68% of lower of the tape? So middle 68% is about the 1 sigmas. So it is in between 1 sigmas is between 24.5, which is in 1 sigma, (25.5 meters). And what percent of the rows are longer than 26 meters? So these are only, so data observation, which is greater than 26 are in here. And we know that these are actually outside of the 2 sigmas. And we already know that 2 sigma takes the 95% of the data. So this one plus this one takes the 5% of data. So, and it is symmetry, so it takes 22.5% of data. So it is 2.5%. Does it make sense? Okay. And next question is about what percent of the rows are between 25 and 26 meters? So these are actually in this range. So we know that this range takes 2 sigma, so it is just 95%. So half of it just take the half of 95%, which is 47.5%, right? Okay, good. Because we only take half of the 2 sigmas, right? Between 2 sigmas. And the last question is about what is the probability as a percent that a row of tape is less than 24.5 meters. So less than 20.5 meter is here. And we know that, okay, so this whole part take 50%, right? And, oh, sorry, not this one. And this small part is half of 1 sigmas. So, and we know the 1 sigma is just half of 68. So is it 68? Yes, 68. So it is 34%. So 50% plus 34% is 84%. So the remaining of the complement of this is 16%, right? So it is 100% minus 34 minus 50. So it is 60%. Okay, yeah. Does it make sense? Or do you have any question on finding this percent? Actually, that's the reason why we run these 6 sigmas or sigma things. So yeah, I'm a PhD student, but before entrancing this university, I worked with some consulting company in South Korea in 2 years. It is a kind of branch of some M company, but anyway. So, and when you go to some consulting company, then all you need to do is figure out the numbers, not the exact number. Actually, exact number is just trash, but you need to know the magnitude of numbers, so that how this number is effective for your jobs or your analysis. And this sigma thing is very well used in the consulting situation. For example, when you say something about your quality of product, or when you say something about your financial status, they always say about this sigma notation. So I hope that even if you don't remember about what the quartile is, but please remember this sigma thing, especially if you want to go to the business part, right? So, okay, so there are some other questions, but I will put it as an exercise and I put it in the radar. And now let's call it a day, and I will let you know the password for the quiz 4. Okay, thank you. Mm-hmm. Yeah, if you don't take the quiz, that it doesn't affect your grade. But if you take the quiz, then you can get extra credit for exam 1. Really extra point, yes. 2.5 extra point on exam 1. Yeah. Yes. Great. Okay. Oh, quiz password. Oh, yeah, I will let you know quiz password. Give me a second. I think that. Yeah, honestly, it is three letter word, but I forgot right now, so I need to see again. So yeah. Thank you. Have a good day. So quiz password is okay. Come on. Oh. Yeah, it's STAT. STAT. Thank you, Morgan. Do you have any other question? Thank you, Karen. Okay, then I will stop in right now. But if you have any question, please let me know by email.